Alrighty, ladies and gentlemen. So, next, we're going to be working with modeling a real world equation with algebra tiles. Or, well, anything that state expects you all to know, ladies and gentlemen. Alright, so here they're giving us this example here, okay? If y'all recall, previously we had worked with examples like that. Remember, they'll give you guys a key, which in this case, ladies and gentlemen, these larger rectangles or these longer algebra tiles, they represent x's. And how many do we have here? We have 1, 2, so that's represented as 2x. Here we have 5 smaller ones or 5 little squares, which can represent positive units. And we have our equal sign. Then on this other side we have 3 positive x's or 3 positive longer rectangles, so that's represented as 3x. However, if y'all notice here, ladies and gentlemen, our little squares here that we have here are shaded in, which in this case represent negatives. Alright, so to solve this question, remember guys, it's 2x plus 5, ooh, that's horrible, plus 2x plus 5 is equal to 3x minus 3. Ladies and gentlemen, please do not forget the steps or the strategies that I suggested y'all use. Remember, let's go ahead and move our variables from one side to the other. My suggestion, although either way would work, in my opinion, or my suggestion is that moving it to one side rather than the other might make it a little easier. Here, I'm going to subtract 2x from both sides. That way I'm left with positive coefficients or with positive variables. So those cancel out. We haven't done anything to our 5, so let's bring that straight down. Is equal to 1x minus 3. Now we add 3 to both sides, ladies and gentlemen, and we've established that x is equal to 8. Alright, kiddos, but another thing that they can ask y'all to do, they could either ask y'all to solve it, or they can ask y'all to compare, to see which model represents the following equation. So here, ladies and gentlemen, they're telling us, as I just said, which model represents the equation 4w plus 3 is equal to negative 3w plus 6. Alright, so looking at our different answer choices, ladies and gentlemen, let's look at the first one here. Alright, so letter A, we have 1w, 2w, 3w, 4w. Okay, that could be true. And we also have 3 positive units. Bingo, okay, that makes sense. Let's look at this next side here. We have negative 3w, which makes sense because here we have 1 negative w, 1 negative w, another negative w, for a total of 3 negative w's. However, if we look at our units, ladies and gentlemen, here we only have 2 positive units, and here it's plus 6. So in this case, A is not the answer. Could it be letter B? Well, let's see here. If you guys look, remember, we have here a negative 3w on letter B. I'm sorry. Here we have 3 positive w's. Here we have 4 positive w's. That can't be it. Same thing with letter C. Although we do have 3 negative w's, we also have 4 negative w's, which if you guys look up here, they were positive and not negatives. So then let's look at letter D. Here we do have 4w and 3 positive units. Great. Yeah, that does satisfy that side of the equation or that expression. Looking at the other side here, here's the negative 3w and the positive 6 units. So that does also satisfy that as well. In this case, ladies and gentlemen, letter D is the correct answer. Alrighty, kiddos. So, on number 21, they're telling us that Fred buys a binder for $4.50 and 6 reams of paper and 6 reams of paper. Latasha buys an ink cartridge for $17.50 and 4 reams of paper. Both spend the same amount of money. What is the price of 1 ream of paper? Alright, so, ladies and gentlemen, to determine the price of 1 ream of paper, we have to set up an equation. Here, we're discussing 2 different individuals. We have Fred, and we have Latasha. So, let's work with Fred. Fred, they're telling us that he bought a binder for $4.50. However, is that all that Fred bought? No, Fred also bought 6 reams of paper. So when you go to the store and you buy 6 reams of paper, are they going to subtract it from you? Are they going to divide it, multiply it? No, they're going to add it to your total. So plus the $4.50 that he spent on a binder, plus the 6 reams of paper at X amount of dollars each. And that's Fred. Now, Latasha, on the other hand, let's see what she did. Latasha, they're telling us that she bought an ink cartridge for $17.50. Is that all that she bought? No, because she also bought 4 reams of paper at X amount of dollars each. And that is the expression expressing what she spent at the store. However, on the statement, or in the statement, there was a key piece of information there, which is the word same. In mathematics, the word same, ladies and gentlemen, means equal. So they're asking us, these two, their expenses were the same, so how much does each ream of paper cost? Alrighty. So to solve this equation, ladies and gentlemen, it's just a regular two-step equation. So first of all, let's go and move our variables from one side to the other. And like I said earlier, moving them to one side rather than the other might make it a little easier, or a little better, or less room for error because we have positive coefficients or positive variables. My suggestion here would be to subtract 4x on both sides. That way we're left with positive 2x instead of negative 2x. So those cancel out. Let's go and bring down our numbers here. $4.50 plus 2x is equal to $17.50. Let's go and subtract $4.50 from both sides to try to isolate our variable. So right here, those cancel out, ladies and gentlemen. We're left with 2x being equal to $13. Now the opposite, or the inverse operation of multiplying x by 2 is to divide it by 2. What I do to one side, I do to both sides. And ladies and gentlemen, we've established that every ream of paper is $6.50.